We're going to do a couple of exercises in the mid-chapter and the end of the chapter. We're going to do exercise 4.8 or 4-8 on page 150 of chapter 4. And it says the result of a census of 2,500 employees of a mid-sized company with 401k retirement accounts are as follows. And if you look at the table itself, it tells you that the amount of people that have an account balance in their 401k that is less than $25,000, we have 635 males and we have 495 females. If we look at the second row, which is the amount of people, males and females, that have an account balance in between 25,000 and 49,999, we have 185 males and 210 females. And if we look at the amount of people that have an account balance between 50,000 and 99,999, we have 515 males and we have 260 females. The account balance, the amount of people that have an account balance over $100,000, we have 155 males and 45 females. Now suppose that researchers are going to sample employees from the company for further study. And it says, Part A, based on the relative frequency assessment, what is the probability that a randomly selected employee will be female? So basically we count all the females and then we divide it by the total amount of outcomes. So we pick our calculator up. Alright, so we have 495 females plus 210 females plus 260 plus 45. So we have 1,010 females in the whole sample. Then we count, so 1,010 females. So we go back to our Word or back to our notebook and we say females are 1,010. All the possible outcomes is equal to, and then we bring up a calculator again and we count again. So what are the males? 635 plus 185 plus 515 plus 155 plus 1,010. We have 2,500, which is the same exact number as the 2,500 employees that we set as N over here. So then what we do is we do 1,010, which is the amount of females, divided by 2,500, which is N. So we have the probability of a female being chosen is 40.4%. So A would be 40.4%. Obviously, you always turn it into a percentage. Part B says, based on the relative frequency assessment, what is the probability that a randomly selected employee will have a 401k account balance between 25,000 and 49,999? So this does not exclude males or females. It does not separate. It just tells what is the amount of people that have in between this account. So then what happens is we look at how many males have between 25,000 and 49,999, there's 185 males and 210 females. So we have 395 people that have a 401k retirement account between 25,000 and 49,999 divided by the total amount of outcomes or total amount of observations, which is 2,500. So we would have a 15.8% is the possibility of selecting an individual who has a 401k account between 25,000 and 49,999,000. All right, and then we have part C, which is what is the probability that a randomly selected employee will be a female with an account balance between 50,000 and 99,999. So then you just look at the females. So you delete this. So how many females have in between that account? Well, there's only 260 females divided by the total amount of observations, which is 10.4, which is 10.4%. 10.4%. So there's a 10.4% chance that you will select a female that has an account balance between 50,000 and 99,999. All right, the second example that we're going to do is example 4.9. 4.9. And example 4.9, it says cross-county bicycle makes two mountain bikes models, XB50 and YZ99, in three distinct colors. The following table shows the production volumes for last week. It says part A. Now we see that the color, we have the model in the first column, we have the color in the second column, which is blue, we have brown color in the third column, and then we have white color in the fourth column. It says, based on the relative frequency assessment method, what is the probability that a mountain bike is brown? So then what we want to do is we bring up the calculator and we look for N. Basically, what is the total amount of bikes in this particular example? So we have 302 bikes. Oops, hold on. 302 plus 40 plus 105. Not 205, 105 plus 205 plus 200 plus 130. So we have 982. So our N would be equal to 982. The next thing is we want to look at what is the relative frequency assessment? What is the probability that a mountain bike is brown? So how many mountain bikes do we have brown? So we have 105 in the XB50, and then we have 205 in the YZ99. So then we have 105 plus 205. So we have 310 divided by the total amount of them, which is 982. So we have 31.57. So our A would be 31.57% chance that a bike is brown. Now, before we go any further, let's add all of the bikes again and see if we get the same amount. We do not want to make a mistake on that. Plus 40 plus 105 plus 205 plus 130 plus 130 plus 200. 982. Alright, yep, that is correct. Then the second one, what is the probability that a mountain bike is YZ99? So then we open up again and we open up the calculator. So we have 40 in the color blue plus 205 in the color brown of the YZ99 plus 130 in the color white. So we have 375 YZ99 models. Mountain bikes divided by 982, which is the total amount of outcomes. We have 0.3818, which we rounded up to 9, so 38.19% chance that the mountain bike is YZ99. Then we have C, which is what is the joint probability that a randomly selected mountain bike is YZ99 and brown. So basically, I'm including not only the row that has the YZ99, but I'm including the row that has the XB50, but in the brown color. So we go back to the calculator, and we say we have 40 plus 205 plus 130 plus 105. So we have 480 divided by 982. So we have 48.88%. 48.88% chance that a particular the joint probability of a mountain bike being YZ99 and also brown. Part D says, suppose a mountain bike is chosen at random. Consider the following two events. The event that model is YZ99 is chosen, and the event that is a white product is chosen. Are these two events mutually exclusive? And explain. You actually do not have to worry about this question at all. Make sure you just understand part A through C very well.